Hi, I Aziz welcome you to CoedMaster, and in this video I am going to solve a problem. The problem is given as we are given a number and we have to find that whether a number is palindrome or not. So let's get started. Let's see this problem. We are given a number and our task is to find that whether the number is palindrome or not. So before we move on, let's understand what is meant by palindrome. A number is called palindrome if after reversing a number we get the exactly same number as the original number. Let's see with an example. See, this is a 4-digit number and if we reverse it we get 7498 and that is not equal to 8947. It means this is not a palindrome number. And one more thing, a number is called palindrome even if you read a number from left to right or right to left, you get exactly same number. Let's see this number. This is 3-digit number. Whether you read it from left to right or right to left, you get the exactly same number as 1 to 1. That is why this number is called palindrome. Let's see this example. This is 555. This is also a palindrome number because even if you read from left to right or right to left, you get the exactly same number. And this is a single digit number. Single digit number is always going to be a palindrome number because if you read from left to right or right to left, you get exactly the same number. And here we are assuming that our number is going to be always greater than 0. So I hope now you understand that what is palindrome and why the output of this input is false and the output of this input is true. Before we move on to solution, let's see an interesting property of 10 again. So when we divide any number by 10, we get a number and in that number, the number of digits is 1 less than the original number. Let's see here. We are dividing 346 by 10 and we are getting 34 only. It means the last digit is gone. And if we divide 754 by 10, we get 75. It means the last digit, that is 4, is gone. So whenever we divide any number by 10, we get a number and in that number, the number of digits is 1 less than the original number. It means the last digit will go away. So whenever we have this type of scenario where we want to remove the last digit, we use this property. Okay. Now let's see the second property. So in this property, whenever we do a modulus with 10, we get the last digit. Let's see with an example. So let's say here we have 346. When we are doing modulus with 10, we get 6 and 6 is the last digit in 346. Similarly, when we are doing modulus of 10 with 754, we are getting the last digit, that is 4. So whenever we want to get the last digit of a number, we simply do a modulus with 10. So now let's use these properties of 10 and try to write an algorithm that takes n as an input and check if a number is palindrome or not. So let's discuss the idea. The idea is simple. First, we initialize a variable reverse with 0 and we run a loop, and in each loop we check if n is greater than 0 or not. And if n is greater than 0, then we do few things, and that is we get the last digit of a number, we do some calculation to get the reverse of a number, and then we simply remove the last digit. And we repeat this process until n becomes 0. And when n becomes 0, we simply compare our number with reverse and return true if the number is palindrome and false if number is not palindrome. So this is the simple idea. So here we have a function. The name of function is palindrome and this function takes n as an input. So what we are doing in this function, we simply storing our value of n in temporary variable. Why we are doing this? Because in each iteration we are removing the last digit and we are getting the last digit. So we want to keep our n intact. We do not want our n to change because in the last step we want to compare the reverse number with our original number. That's why we are storing the value of n initially in the temporary variable. So let's quickly do the dry run of this problem. So let's say the initial value of n is 8947. So in the first line, we are simply assigning the value of n to temporary variable. So the value of temp is going to be same as n, that is n8947. And initially the value of reverse variable is also 0. Now when our execution begins, our loop gets started, and in first iteration it checks that value of temp is greater than 0. Yes, it is, because 8947 is greater than 0. So when this condition becomes true, we get into the loop, and what we are doing, we simply getting the last digit from the temporary variable by doing modulus with 10. So we get the last digit as 7, and then we are calculating our reverse number, and we are simply doing reverse into 10 plus LD. By doing this, we get our reverse as 7, and we simply removing the last digit, and we get temp as 894. In next iteration, the while loop again checks if the value of temporary variable is greater than 0 or not. This time it's greater than 0. The condition becomes true and we get into the loop, and simply we get the last digit. This time the last digit is 4, and we find the reverse number. Now this time we do reverse, that is the 7 into 10, that is 70, and we add 4 to it. It becomes 74. And we simply remove the last digit. So our temporary variable holds 89. Okay, let's move on to next iteration. In third iteration, we simply get the last digit, that is 9. See here, we get the line, we get 9, and we find the reverse, that is 74 into 10 plus 9, and it becomes 749. And we simply remove the last digit from the temporary variable. In fourth iteration, the loop again checks if the temporary variable is greater than 0 or not. Now again, the value of temp is greater than 0, the condition becomes true, and we get into the loop. Now we find the last digit, that is 8. Then we calculate the reverse again, that is 749 into 10 plus 8. It's going to be 7498. And this time when we divide temporary variable by 10, our temporary variable value becomes 0. And in the fifth iteration, our loop stops. And what we are doing in the last line, we are simply checking if the value of reverse is equal to n or not. And you can see that the value of reverse is 7498, and that is simply not equal to 8947. So this function returns false. Let's see another example. Now this time the value of n is 1 to 1, and we can say that this input is palindrome. So let's try run this program to see how it works. Okay, so first of all our n becomes 121, temporary variable also becomes 121, and the value of reverse is 0. In first iteration, we get the last digit as 1, we find the reverse, we calculate the reverse, then the temporary variable becomes, then the value of temporary variable becomes 121 divided by 10, we get 12. Okay, in next iteration, our last digit is going to be 2, and the reverse will be 1 into 10 plus 2, that is 12, and our temporary variable will become 1. In next iteration, our last digit is going to be 1, we get our reverse as 121, and the temporary variable is going to be 0. In fourth iteration, our condition becomes false and the loop gets stops. And this time we simply checking the reverse is equal to n, and that is our reverse is 121, and that is equal to n. So this time this function returns true. Now let's talk about the time and the space complexity of this solution. Now talking about time complexity, we are basically running a loop. How many times? The number of digits in our number. So if we are passing a number that is having a 4 digits, then we are running a loop 4 times. And if we are passing a number that is having 3 digits, then we are running a loop for 3 times. So we can say that the time complexity of this function is going to be theta of d, because the time taken by this function is simply depends upon the number of digits in a number, and this is the exact bound. That's why we are using theta here. Now what about the space complexity? Now in this function we only need space to store the temporary variable, reverse of a variable and the last digit variable. So basically we need 3 memory space to store this 3 variable. So n3 is a constant, so and we are not using any extra space other than this. So we can say that the space complexity of this function is going to be theta of c, that is constant. I hope you got it. This is it for this video. Thanks for watching. See you in the next video.